Hi everybody. I'm Gant Laborde. Hello. Hi. A couple things about me. I was CTS of Infinite Red. It's a wonderful company, and one of the great things that they did recently is they really do care about their employees. And I can say that because I went from employee, and I just released the blog post yesterday, to part owner. So actually, they really, really care. Like, there's no barrier to entry. It's a wonderful place to work. I work often with a lot of React Native and mobile apps, so if you want to talk about React Native and you want to talk about JavaScript inside mobile, I'm very happy to talk to you about that. We run the conference in Portland every year, Chain React, so if you want a conference discount, come talk to me and I'll get you to Chain React, easy enough. And then additionally, machine learning wasn't taught in school when I was in school, and it's a buzzword now, right? And so I kind of was like, okay, I guess I'll kind of hear about this. Maybe some of you, how many of you actually do machine learning? Exactly, right? I saw one person in the back who thought I didn't see their hand. No, I saw it. And here's the thing, right? My talk to you today is going to be trying to show you how important, how different, and how much all of you will have to do machine learning pretty soon, and then how approachable it really is. So if you'd like to stay in touch with me, these are the forms of contact, so we can definitely chat and continue on that. That's a good one for the photos, I see. And then you'll often see me by riding the unicorn of science and truth. As you can see there, the unicorn has goggles, for safety is top priority. And then I have to again say, like, thanks so much to the great people at Infinite Red. They send me to wonderful places or allow me to just go ahead and run off to certain spots like this. And if, by the way, you want to tell everybody about me, then go ahead and make sure to tweet the people at Infinite Red. If you hate this presentation, I work at Formidable Labs, so no problem, I got you. So it's important to start off with why. Why is Gant talking about machine learning? And machine learning is sort of like, as developers, I've seen several talks about reusability of code. And we're very interested in making sure that what we are doing has a significant positive impact in what it is we are trying to accomplish. Certain salesmen will say, you don't buy a book, you're buying a story. You don't buy a movie, you're buying an experience. And by that same fact, us as coders, sometimes we can get into the puzzle solving and the fun, but what's really kind of key for me here is that machine learning gives us that sort of like ability to take our code in new and more grand places. So if I were to write something like Grammarly, which would help me with my comma splices and my punctuation and my misspellings in English, if I were to sit there and code every aspect of that and get a mastery of the English language enough to write all the rules, then somebody says, we love it. By the way, internationalization's really key. Can you come over here and do it in Italian? I'd be like, no. I couldn't even order gelato. I am going to fail terribly at this. And so the grand idea here is that I will be able to write a machine that I'm able to train in English, and then I will also be able to go ahead and train it in many other languages. So write once, train for anywhere. And this is like an interesting kind of new concept for a lot of you, but we are all prone to care about that, right? You don't want to write the same component 5 times in 5 different frameworks, right? Nobody here is like, hey, I'm going to go port that over to jQuery. We're good, right? Okay, good. So why machine learning? It's the power of it, right? And I don't know why, but for some reason, Nicolas Cage shows up in everything having to do with machine learning. This guy is in all stuff before I got into machine learning. So everybody thinks that I'm obsessed, but the truth of the matter is this is like an ongoing thing. Why else should you care? Well, if you take a look at the major industry creators and the people that we really aspire, I know a ton of people are always willing to work with Google and they're really happy. I mean, some people are cool enough they can just turn it down and say, nah, I'm done with you, Google, but a lot of people really care what they're doing. You know, they're the disruptor, they're the creators, they're sort of like the industry. And Google themselves had next to no machine learning in 2012. And this graph, I know it's a little too small for you to see, but if you take a look at this, at the end and the beginning, so at the beginning of 2017, they had over 4,000 TensorFlow models in production. If you want to know where they're putting the wood behind the arrow, you're looking specifically at machine learning. They are hiring, they are building, and they are working on machine learning. How many of you have Gmail and it actually is finishing your emails for you? And you have to hit tab and it just finishes the email. Every time you hit tab, what do you think you're training? Every time you fill out a CAPTCHA, who do you think you're helping? You're actually helping Google build a bigger and more impressive model. So what does machine learning do, right? We know why people care about it now, but what does it do? And I actually have a little intro that I did for when I actually did a speech at Amazon, and I had a whole thing about, believe it or not, and some of you have seen it at React Native EU, Nicolas Cage. And for my intro, I decided to employ deep learning in order to have Nicolas Cage, who's a good friend of mine, of course, give me my intro. So if y'all don't mind, it's only about 5 minutes long. Do y'all want to see the entire intro that I did at Amazon? It's pretty good. It'll help wake you up. This is obviously the rock star himself.
Hello, Amazon. When my good friend Gant asked me to introduce him, I said, whoa, of course. So he's there, and he's going to show you some cool stuff, some really freaky stuff with machine learning. And to accent the point, to really drive it home, I did what I do best. No, not steal the Declaration of Independence. Though I might do that too. I made a movie. So get ready to get your minds freaking blown. Enjoy the show.
And then he did this by himself, okay? I had nothing to do with this part.
Breaking news tonight. The Declaration of Independence will be going on tour.
Nothing can stop me this time.
Hello, Nick.
Hello.
I know what you're up to.
What do you mean?
I know you're planning to steal it.
You know what?
The Declaration.
How absurd.
I'm going to stop.
He has little photos
I'm going
of
to
himself.
find a way. I'm going to build an app.
Good luck. You're gonna need it.
You're going to need it.
How to get burned? How to get burned? How to get burned? Hello.
Goodbye, Nick.
There you go. Fantastic. Thank you. Thank you. Now, my friend Frank looks nothing like Nicolas Cage, as you can tell. And if you don't know who that is, then that was actually him, and I'm famous in the States. Okay, but no, but actually, he looks nothing like it. We just superimposed, using machine learning, Nicolas Cage's face. And this is starting to get very frightening for a lot of people. But that technology took me a weekend to figure out, so that way I could have it ready for the presentation. It was not difficult at all. Actually, the editing took longer than superimposing the face. So that's pretty impressive stuff. Everybody's seen Star Wars. They've brought people back from the dead to be in new Star Wars movies. It's pretty scary and a little bit impressive. And then here's some other cool things that I want to show you that machine learning can do. Imagine that, so this just recently happened at the beginning of the year. Imagine you're trying to pick out colors of hair dye, and you want to know what it looks like on you. That's not something you can get very wrong and be okay with, right? But here we see somebody trying it out in real time. It's specifically using machine learning to get the region detection and then style transfer of that color directly over the hair. And it looks amazing, right? And as our phones get more and more adaptive, as our operating systems get more and more adaptive, it gets cooler. And actually, I have a friend of mine, so we did a product at Infinite Red where we were superimposing color for makeup. And so people were able to try on different styles of makeup instantly by just clicking a button. And as we were testing it, my friend Leon, late at night, I think he enjoyed this way too much. But these are the demo videos of him actually working with that specifically. So you see him changing it. So it's pretty important to think of some cool uses of it. And anybody here work remote? Anybody sort of like have to call into calls? This is a fantastic thing called GrUSP AI, which helps take out background noise for you. So you could be in an airport or have a loud screaming kid, and it's using the cocktail algorithm to subtract out that background noise. We have any death metal fans in here? They have, yeah. There's people who created AI-generated death metal, and I'm not good enough to tell that it's fake. But it is live streaming all day, never stopping. The link's inside the slides. You can listen to it all day. Brand new, computer-generated death metal for you. These are the things I think computers should be doing, right? Taking photos and actually just doing Photoshop for you. This is an open source repository called Deoldify. You could do this on classic movies, black and white movies that can suddenly become in color with zero personal interaction whatsoever. And then those of you who have parking problems, you can set up a camera and identify when a parking space finally becomes available. These are really fun, really interesting creations, and these have all happened this year. The people who are going to be creating the cool, interesting, and wildly innovative ideas are going to be doing it now, and hopefully some of you. But I would like to take a moment to say, what should it do, right? We can apply it to fun and interesting things. We can swap faces out and make movies. Well, several people are using this for the greater good, right? And that's sort of an initiative that's very centric to Infinite Red and a lot of the people I know. They want to give back in some way. And so if you take a look at this is the maps. This is free maps, and people would suggest some building architectures at certain times, and they would say like, okay, here's the buildings, they would lay it out. If you want a competitor to Google Maps, you need to use Open Maps. But people just didn't have time to go ahead and do all these particular buildings until Microsoft came along and said, hey, we applied machine learning to satellite photos, and this was 14 years of work by humans. And then, in one night, go ahead and watch the screen carefully so you don't miss it. That is what Microsoft contributed back, 125 million buildings. Then they took the software and the algorithm that they used and open sourced it. So anytime there's any kind of satellite updates, we can get updates as well, contributing back to humanity. We can take jobs that are dangerous or boring, and we can automate them. And then additionally, another thing that's very near and dear to my heart is the people that we love. we can help them live a better life. So we can outperform doctors in cancer. We can make sure that if you ever go under for any kind of surgery, that you'll be taken care of, and that we can even detect disease before any doctor possibly could. These are all brand new applications of this. As a matter of fact,
And so that has led to development of powerful applications in all sorts of areas. You were talking to me the other day about cancer. Can I show this video?
Yeah, absolutely.
This is cool.
So this is kind of an insight into what's happening in a completely different domain. This is augmenting or competing, it's in the eye of the beholder, with people who are being paid $400,000 a year. Dermatologists, highly trained specialists. It takes more than a decade of training to be a good dermatologist. What you see here is the machine learning version of it. It's called the neural networks. What my student team at Stanford has shown is that if you train it on 129,000 images of skin conditions, including melanoma and carcinomas, you can do as good a job as the best human dermatologists. And to convince ourselves that this is the case, we captured an independent data set that we presented to our network and to 25 board-certified Stanford-level dermatologists and compared those. And in most cases, we're either on par or above the performance classification accuracy of human dermatologists.
You were telling me an anecdote, I think, about this image right here. What happened here?
This was last Thursday, and that's a moving piece. So what we've shown before, and we published in Nature earlier this year, was this idea that we show dermatologist images and our computer program images, and we count how often they're right. But all these images are past images. They've all been biopsied to make sure we have the correct classification. This one wasn't. So this one was actually done at Stanford by one of our collaborators. And the story goes that our collaborator, who's a world-famous dermatologist, one of the 3 best apparently, looked at this mole and said, it's not skin cancer. And then he had a second moment where he said, let me just check with the app. So he took out his iPhone and ran our piece of software, our pocket dermatologist, so to speak, and the iPhone said cancer. It said melanoma. And then he was confused and decided, okay, maybe I trust the iPhone a little bit more than myself. And he sent it out into the lab to get it biopsied. And it came out as an aggressive melanoma. So I think this might be the first time that we actually found in the practice, using deep learning, an actual person whose melanoma would have gone unclassified had it not been for deep learning.
I mean, that's
Wow.
incredible.
A pocket dermatologist, $400,000 doctors, and being augmented by this ability to sort of save lives. And the applications that people are coming up with every day are impressive, range from impressive to absolutely boring as well. Depends on what your interests are. So what I want to say is that any of you who are currently saying, okay, Gant, I accept this. It is obviously something that's coming up. It's something that people are investing money in. It's something that I'm probably going to see in my career. What is it? And if you go ask that question to any person who's already doing machine learning, you'll usually get, no problem, just go ahead and take these 18 months of courses and then figure everything out for yourself, and then come back, and then we'll start talking about how you can start to build something that will do a little bit better than just basic statistics. And it's a very annoying process because it's sort of owned by academia right now. And this is the thing that, if you went to college for it, if you have a PhD for it, I mean, you're doing fantastic. But most of us are just developers, and we're developers in countries throughout the entire world. And we like coming here and working in languages that we already understand. We want to do it in JavaScript. We want to do it in every language that we can actually work with. And so I'm not going to do the math. I hate machine learning talks that just start you off with a bunch of math. Now, if you want to talk about the math, I was the idiot who did the 18 months of courses, so I will be happy to talk to you about that part. But you don't have to do that right now. Actually, I'm going to talk to you like developers. And so I want you to know, you're going to hear a certain word. You're going to hear a word called a model. And a model has layers, okay, like ogres and onions. And so a model, and you hear that word, just think trip equals, because we're doing JavaScript. Just think function. That's it. Think microservice. Think function. You have a function. Now, that word doesn't have any power over you. Yes, it is a function, and then yes, it's a little complicated and different. It says a lot more about it, but to handle it, that's it. And so Gant, what do you mean by it being a function? I mean specifically, I take data, like some photos of some people, I put it into the function, and then I get data out, and that is whatever that function was supposed to do. Maybe it tells me the age of all those people, each person's particular age. Or maybe it tries to tell me their sentiment, like are they happy or are they sad in those photos? And that's it. That is actually just a function, right? So now you know that you can do machine learning just like you can code. So where do you get these models from? Where do you get these functions? And the truth is there are 3 places where you get these. And then this will feel very much like when you are just programming. 1, download an existing model. If I have one that identifies types of food, then you just download it, you put it inside your website or your app, and then you upload pictures of food or you work with it, and then it tells you what it is. There's a lot of them out there. It's just like getting something off of NPM. But there's currently no NPM for models. Aha, ideas. So you could just download one that exists. Another place is, and this is what almost everybody tells you to do, train your own model. Go ahead. What are you doing tomorrow? Okay, just go ahead and take out the rest of the month, and you are going to build a model now. And that's it. You're just going to have to get a bunch of GPUs flown in. You're going to have a machine that's cooking your entire office, and then you're going to train your own model. And this is where all the math kind of gets involved in. Don't accept that. Anytime people are like, hey, let's train a model from scratch, and spoiler alert, we'll train one from scratch in a little bit. Don't think that that's something that you have to do. That's not something you always have to do. If you have a very simple task, then just consider specifically there are better options, right? And then additionally, this is what everyone does. The Stack Overflow. They take a simple model and they just go ahead and they modify it a little bit. And so that's pretty cool. So it takes something that's similar, we modify it a little bit, and then we put it on there. So where is this currently? Well, there's a bunch of different libraries. There's different sets of code. It's all over the place, right? Because like I said, it's just basically run by a bit of academia and Fortune 500 companies. So how do we bring this all together? And my suggestion is that I think we can use JavaScript. JavaScript's everywhere, so why couldn't we possibly just use JavaScript? And the truth of the matter is, but it's limited. Okay, get out of here, pair programmer. Nobody wants you. See you in your dreams, Gant. Okay, get out of here. So JavaScript options, specifically, you have several of them today. There's TensorFlow, which everybody's heard of, TensorFlow Lite and TensorFlow JS. You have Brain JS, which is just JavaScript, aka Brain. And then you also have like certain libraries that are going specifically to mobile, like CoreML, right? And so if you're planning on using this, though JavaScript goes everywhere, it's currently, like I said, there's a lot of discrepancy on what's going on here, and you can be the person who hooks up and builds the bridge between those two islands, builds a product that nobody has ever seen before, and then gets picked up and starts getting some of that insane AI money. So machine learning, currently, I want to give you a quick topology of what it looks like. Told you so! Go away. So specifically, there's a couple of examples I've done for you. This code is all open and available. It's part of the slides. So using TensorFlow Lite, I went ahead and created this thing, which is pretty simple. You just click on images, and then it runs it through the model and tells you specifically what that image is. If you notice when it clicks on taco, since it did not have taco, it thinks it's a pencil box, which which is quite entertaining. But basically, this simple thing, I think they're coming up with like a language trick where you can go around your house, and let's say I was trying to learn Italian, I could go take pictures of things around my house and then get the translation of it in active time. It's like, oh, how do I say apple in Italian? And then I could take a picture of it. It could identify it's an apple, do a simple language lookup, and then tell me what that is. And this is all happening on the phone. This isn't running off and hitting some service. So I can be without any kind of internet connection. This is happening within under a second, right? With React Native and Brain.js, I did an example where there was this classic data set called the MNIST, and they don't have this thing called convolutional networks yet, but even without that, I was able to create a number figure outer. So you can actually, with your finger, swipe on the phone and then see what number the computer is seeing and what it thinks that particular number is. And then on CoreML, I did, just like I said, I downloaded the food model. And with live video, look, there's hot dog, not hot dog. Spoiler alert, we'll get back to that. And so here I am looking at different types of food. All three of these code bases are open source, and they're available. So you can actually look around right now and identify, oh, what kind of food is this? So quite entertaining. And on web, you've got Brain and TensorFlow JS, and I've used that to create a couple of things. I grabbed this one, which it was so nice, I just went ahead and took it. This is an accessibility trainer, so you click which one's more readable for you, and then it ends up getting smarter and smarter to actually tell you what color scheme is going to work. So it's almost like testing whether or not, for a particular person, what their accessibility levels are. And then I took some time and I created NicolasCageOrNot.com, so it's Nick or not. And you give it a photo and it'll tell you whether or not Nicolas Cage is in that photo or not. Very useful. I have to use this quite often, as you can tell. So if you're interested in learning more about TensorFlow, TensorFlow Lite, and TensorFlow JS, this is a wonderful library that I highly recommend. This gentleman's teaching all kinds of cool stuff about it. And then if you're interested in learning more about Brain.js, I highly recommend Scrimba by Robert Plumber. He's got a course, and I don't know if you've ever used Scrimba, but it live codes inside your browser. And then the moment that you're done with it, like you pause it, and you can edit his code live inside of there. It's a wonderful teaching tool, and that's a free course right there. So how do we make a model? So we know we can use them. We could put them anywhere, but now you're like, Gant, how the hell do I make one of these? And so I have a pretty cool example. I would say you could try it out at the same time, but we would destroy the internet. So I'm going to just kind of do this on my machine right here. So I thought what would be interesting is a rock, paper, scissors machine learning model all in the browser. So starting this off, we have this particular data set here, and this was by a gentleman at Google, and he created these 3D hands of rock, paper, and scissors. Does everybody know how to play rock, paper, scissors? Yeah? Or is it Rochambeau? Just making sure. Everybody played paper? Okay, I win? All right, good. By the way, this hand in the middle, that is not how you use rock. If you throw that, I'm calling BS on you. That is a terrible rock. So in this website, we're actually going to train a model together, live, right now. So I'm going to load and show the examples. So when I click that button, I actually loaded in a sprite sheet into the browser. And that sprite sheet has all kinds of examples of those hands loaded specifically from that data set, right? And this little display off to the side, this is called Visor. This is something that you can use in TensorFlow JS if you start to build something that you think is good for the community, sort of like, ta-da, definitely what we'll talk about is NSFW JS. So here I am loading all the different data that's in there. So I have examples. Now I'm going to create a simple shell for the model, what the function is going to look like and what it does before it has any data going into it. So I click Create Simple Model. And then it loads all those layers, like we talked about, over on the right side. And this is a super small number of layers. What is that, like 6 layers, right? And then what we're going to do is we're going to take a look at how dumb this actual function is. So we click check the untrained model. And we get two different set of analytics here, and this is easy enough to read. It thought it was rock. It actually got rock correct 44% of the time, paper right 51% of the time, and it never got scissors right at all with all these samples. And our confusion matrix, which is sort of like the same data presented in the same thing, just has dots everywhere. And then you take a look at our scissors column. It's like, yeah, we didn't get anything. It never thought anything was scissors. And why should it? It's been randomized. It is basically an untrained, just randomly hooked up, ready to go model. And now we're going to train our model. So as I click this directly in my browser right now, we are actually training that model which you saw. And I only have it going through a few setups here, but I'm going to sort of give you some of the terms of art of machine learning, because it's the same stuff that you all know as developers, but under different words. So we have batches, and I currently set the batches at 512 images. So every time we have 512 images, it gives me another dot on the batch. And then when I go through the entire training set, I get what's called an epoch. And we have two graphs, both of them, if you take a look at the top here, this top graph is going down, and that is our loss graph. Going down on the loss graph is good. That means less loss. And then we have the accuracy graph going up. That's obviously good. Now, what's the difference between loss and accuracy? Let's say I was trying to guess how many bedrooms and bathrooms you had. If I said you have 2 bedrooms and 16 bathrooms, and I got the bedrooms correct, then I'm 50% accurate. But I was really far off. If any of you have 16 bathrooms, that you have, yes, please see somebody. But the loss was way off, right? I got 50% accuracy, but the amount of how close I was to the answer was very far. And if we take a look over here, our epochs are reaching an end. I only have it doing about 12 epochs, but you're watching that accuracy go up, and there's an orange bar. I hope everybody can see it. If not, you could definitely try this later. That orange bar is data it's never seen before. There's a set of hands that I took off to the side and said, hey, are you just getting really good at the test, or are you getting really good at seeing these things and generalizing to other things? Have you ever seen somebody who's like really great at a test, and then they get in the real world and they're like, I don't know, I didn't study for this. So the great thing about that orange bar is that that's helping us, and it's called our validation accuracy. So as you can see here, we finished somewhere around 93% accurate with these hands, and we're going to check the model again. So we're clicking that model again, and this is a healthy confusion matrix. We were right on rock 99% of the time. We were right on paper 93, and we were right on scissors 89.6. So it's definitely a bit better, and we can see when we threw rock, we got rock. When we threw paper, we got paper, and we threw scissors, we got scissors, except for it seems to confuse it with paper quite often, and I don't blame it, right? That's kind of a simple mistake to make. So this model that we just created in 12 epochs on our browser, on your client's browsers, taking nothing from your server machines whatsoever, and with 0 internet connection, is about 48 kilobytes. And it's smart enough to handle those really simple images. And what I'll show you here is that if you can really get a really clean background, you can actually get rock, paper, scissors to work with this model. So I have a little webcam here. And what we're doing is we're taking the webcam and we're breaking it down into, oh, I'm the rock. Oh, that's cool. I'll star in a movie. You can see this really small 64 by 64 black and white image, which is what it sees. And so maybe I'll try to go with paper. Let's see if I can get it to do paper. Yeah, it's just like too many angles and too many things. So the white background, there we go. I got a paper. I'm not going after scissors. I saw the stats on that one. And so now, with just a little bit of time, I was actually training a visual graph. And we're able to actually access that. What happens if we want to load in something seriously advanced, right? What if we want to get really fancy with it? And let's see if this actually works live. So let's see, is this? Rock, paper, scissors, rock, paper, rock, scissors. Okay, yeah, not bad. Let's go over my face. Yeah, so this is a 23 megabyte. So sorry, I'm not touching this thing ever again. That was a 23 megabyte model, right? That's something that I spent a lot more time training, and that's something that's done in the browser using my webcam right there, right? So this is getting pretty impressive. So what kind of things can we use? Like rock, paper, scissors, that's not good for social good. So we kind of like asked, what kind of things can we create that would really kind of help people out? And we came up with this idea, Not Safe for Work JS. And Not Safe for Work JS has been trained on my computer at home for weeks upon weeks. And then every time I go to a conference, sure enough, a lot of people like to pull their phone out and they're like, this is hilarious, but don't show me your photos of. So NSFW stands for Not Safe for Work, and it's to help people identify indecent content. I actually have a website here, NSFW JS. And this is that same kind of concept. So the trick is we can do a live camera. We could check these things out. And don't, like I said, don't send me your data right now. I'm not ready for it. And it can identify things as, I'll show you, I'll drag over the classic here. So it says, it's sure it's a drawing, 76.82%. It's neutral, 18, and then hentai, it's going a little bit at 4%. Porn, it's definitely not porn. And sexy, I am not sexy at all, apparently. So it correctly identified this as a drawing. And so this was trained on my computer for a long time. You don't have to train in JavaScript if you don't want to. You could train in Rust, you could train in Python, you can go wherever you want to, and then you can bring this to the users directly in the browser like this. And this is all open source. This is also completely available. And there's another aspect to this. So let's take a look at a neutral image. Oh, that's an animated GIF. Let's see. We'll bring in me again, because I own the rights to these. Neutral, 99%. So it's very sure of that. When I first did this, it kept identifying Jeff Goldblum as sexy, no matter what happened. And I think it's because Jeff can't keep his fingers out of his mouth, but I fixed that. So, so now actually it's even smart enough to be able to identify Jeff Goldblum, unfortunately, is no longer identified as sexy. Now, I have a feature here as well. This opens up new problems. I can tell you right now, I'm showing you problems that people have not attacked yet. And for instance, how do I identify a GIF? So I'm dragging a GIF on there. It's parsing through it, and then it's actually animating it. And if you take a look down here, we get a graph. So here's a person, obviously really good at gymnastics. And as we look at the graph, we can see we started at 74% neutral because it was blurry. Blurriness, for some reason, always tones things down. And you can see that we're going through here. And then we have a dip. I guess when a person is in this position, it's generally not nearly as, but like you can see that we dip down to 81%, and then it comes back up to when she recovers here. And so we're dragging through the images. And this is really cool. So how many of these have to actually have to say it's dirty for the whole thing to say it's dirty? I don't care. The library itself is just telling you that information. But I need to hear from people using this in the field. It's actually gotten better. I found Jeff Goldblum from somebody in the field telling me specifically that that kept showing up positive, and it was hilarious at the same time. And so what's important here is that as you kind of take a look at applying this, how can you use this? And there's different aspects here. I'll go for a second and show you on the slides. I am not brave enough to drag over actual not safe for work content in front of all of you, and possibly because all I have to do is hit the space bar and then my career is over, right? So what we'll do is we'll come back to it. But here's the thing that I want you to know. We don't need to create advanced algorithms anymore. You just have to teach a computer to come up with its own advanced algorithm, okay? We have become the teachers. And this is a new era of coding, specifically. So like I said, you could definitely try out NSFW JS, and and there's a lot of false positives that's kind of happens. So here, actually, just to make sure you know, these are the actual dragged over. I made an animated GIF, so ethically, there's no mistakes that can actually happen here. But you can see that it's actually working with indecent content as well, right? And so these capabilities are fantastic, and the applications, I think, are additional. Now, that is a safe for work picture, everybody. All right? That is a picture of a lamp. Ask any kid. Have many people seen this? And so what I want to say is that it's going to be wrong. That is just a lamp. And not only am I wrong, Google's wrong, and Clarify, which are all services that actually go up to much more powerful servers, not running directly in the browser. Those are wrong as well. And so PhD scientists have found this, and we have to be okay with these things being wrong. Right? So that is, by the way, if you do go through that person's blog post, you will have a heart attack every time you see a new photo, specifically. So I want you to know there are different types of errors, right? And false positives will happen. You, using this app, will be able to find a false positive. But that doesn't mean that we can't use this. If somebody airdrops you a photo right now, wouldn't you want, if you don't know who that person is, wouldn't you like to have it 90% of the way sure and say like, hey, this might be a picture of whatever, but we've identified it's possibly dirty content, right? This is possibly something that users sending back and forth might need to be alarmed about. Maybe you're building a dating site. Maybe you actually have a forum, right? And the issue, or maybe people are uploading things to your website. Maybe you could possibly get in trouble. And it's good to know this, but we don't have the large company dynamics. We don't have a bunch of people we can hire to just look at that content like YouTube does. And so if it actually does flag anything, and it's right 90% of the time, then it saves us as people a lot of nightmares and a lot of work, and we can start to use that. So AI isn't perfect yet, and that's okay. I think that we need to make those mistakes. The fact that I put that code out there and then people said, hey, criticize, the Jeff Goldblum's always like, he's marked as positive, right? That was fantastic. This feedback, as developers, we work in open source. We work in this sort of mentality. And I have tasks for each and every one of you if you actually want to get involved in this kind of thing. The number of ideas that I have for AI is amazing, but the number of ideas that all of you have is so much more important. And I think that's really key here is we have to give each other permission to make those small mistakes. There are different types of errors. So you yourself need to think about where you can apply these things. Not just my library, but what kind of libraries you could actually use. And so there's a fantastic quote, reimagining everything inspires science. Do you know who said this? A bot, inspirabot.me. Made up that inspirational saying. You can actually get inspirational sayings made up for you with backgrounds that possibly fit them. So that's kind of nice. But we're going to be having coffee in a little bit, and we're going to be talking to one another. And I think that you should say it does what a person could do trained with a lot of data in under a second in a scalable way. So what could you get an intern to do if you just gave them a lot of information? And this is something that we could be building and performing as a service. This is something that you can create, you can make that everybody will get to use. And this is the way that I think that you should think about it. And it's important that you actually, when you're thinking about it, you're not afraid, because the fear is definitely the mind killer. One thing I will say, all the fun examples that we have here, I have a newsletter that I've just started yesterday. And so if you're interested in joining and sort of helping me build these crazy and cool things, if you want to integrate those things into your apps and your websites, let's talk about it, right? Another thing I have is a Twitter account called Fun Machine Learn, because Twitter stopped me. It was going to be fun machine learning. And all I do from that account is tweet fun and interesting machine learning things, right? It's the parking spot stuff and all the examples that we sort of started off with. So if you're looking for a little bit less buy-in, feel free to go ahead and just follow that Twitter account. It also has a hashtag that's taken off pretty good, hashtag FML. So I don't know why, but everybody seems to be using it. It works out nice. My key aspect here is that academia and large companies own what is considered the new electricity. They have a grip on all aspects of what is going to be taking jobs, making them better, or making them worse. And I need you to do this for me, because this is a photo of me and my mom. My mom and I go to dinner, actually lunch in this case, after I take her for her cancer treatment. So she has melanoma, and she has a very aggressive melanoma that moved throughout her body, and she's doing fantastic. But when I take her for treatment, we spend a little bit of time together. And you say to yourself, Gant, you showed us a TED Talk where they were able to identify aggressive melanoma on a phone. How you, as a technical person, let your mom get that kind of thing happen to her. And that's where this story gets a little sad for me.
It feels like there'd be an instant demand for an app like this right,
Can you get that
right
back?
now, that you might freak out a lot of people. Are you thinking of doing this, making an app that allows self-checking?
So my inbox is flooded about cancer apps with heartbreaking stories of people. I mean, there's some people have had 10,
Need the
15,
audio
20
back.
melanomas removed and are scared that this one might be overlooked like this one. And
don't
also
need it.
about, I don't know, flying cars, speaker inquiries these days, I guess. My take is we need more testing. I want to be very careful. It's very easy to give a flashy result and impress the TED audience. It's much harder to put something out that's ethical. And
So what he says there is, and I hope everybody heard it, it's too early. It's harder to put something out that's ethical. So it's not out. That app doesn't exist. You can't check any kind of skin condition right now. And I understand what he's saying. He's saying he doesn't want to mess up a medical industry of doctors who specifically have claimed that their oath is to take care of you. With that technology, beating the best at Stanford, in my opinion, that app should be on everybody's phone. It should come with your phone. The fact that he has that technology and it is not available. Penicillin was released just openly without patent. Insulin, which some people need in order to live, the patent for insulin was sold for $1. Why? Because it's important for us. And the scientists who made those things knew how important they were. They didn't hold back on that. They didn't keep it. They didn't check it over and over again to make sure they weren't going to piss off their business buddies. And that's why I have this quote that inspired me to start into machine learning by Chris Hyman. We can hope that others use this power for good. For one, I don't consider this a good bet. I'd rather play and be part of this revolution, and so can you. And that is the important part. It's something all of you can have, do, and work with to make the world a better place. When industry shows up, it either improves lives or destroys them. And we are at the beginning of another revolution, like the Industrial Revolution, but this will be an AI revolution. And I think that all of you need to take part in that, Not for me, but for the people that you care about, for the lives that you are responsible for, and those who are important. Now, to make sure that you're all inspired and not sad, I actually have a fantastic closer and a motivational speech to each and every one of you. So I want you to know, if you've been waiting for permission to get interested in machine learning, if you've been interested in building significant positive impact, you don't need to wait for Google to give you permission or any other company. What you need is just for you to join the revolution. Thank you.